You are falling from the surface into total darkness. Sunlight fades fast, and the seawater grows colder. 100 meters, 300 meters, 600 meters. Temperatures keep dropping, and pressure builds relentlessly. No coral here, no seabirds, no light at all. Only countless faint blue-green glimmers drift slowly through the blackness. And you keep accelerating, because you are a swordfish. You barely stay near the surface by day. Every sunrise, you dive down to the 2080 meter twilight zone. Occasionally you push even deeper, into pitch black waters below 100 meters. One recorded swordfish once dove to 164 meters. No sunlight reaches that far. The only light comes from living creatures that make their own glow. You do not come here to hide. You come here to hunt. What you chase is not one single animal. It is an entire moving mass of life. Every night, hundreds of millions of lanternfish, squid, jellyfish and other small creatures rise toward the surface to feed. When day breaks, they sink back down into the deep sea. This is Earth's largest-scale animal migration. During World War I, when humans used sonar to hunt for submarines, they detected a shifting, rising gandfalling seafloor in the ocean. Later they learned it was no real seabed. It was the massive deep scattering layer made up of millions upon millions of living beings. They move up and down each day, and you move right along with them. Most large predatory fish do not follow this migration full-time. Marlin and sailfish dive deep at times, yet they mostly stay within warm waters. Tuna also pursue the scattering layer, but few dive day after day into the cold dark the way you do. For most fish, these depths are far too cold, but your body evolved exactly for this world. As you dive, seawater temperatures plummet. For ordinary fish, metabolism slows, muscles stiffen, and eyes lose their sharp reaction speed. Your body switches on a different set of systems. Your massive tail muscles generate constant heat. These swimming muscles sit close to your core, wrapped in an intricate network of blood vessels that trap heat inside, instead of letting it escape with circulating blood. Even surrounded by frigid water, you can keep swimming at full power. Yet your muscles are not your most extraordinary feature. It is your eyes. One of your extraocular muscles has nearly abandoned its original job. It no longer mainly moves your eyeball. It has turned into a natural biological heater. It burns energy non-stop purely to produce warmth. That heat flows straight to your eyes and brain. In cold conditions, retinas slow down when processing light. Prey gives off only a split-second glint. If your reaction lags even a little, they vanish. So you keep your eyes warm first. Then you keep your brain sharp. You are not a full-blooded endotherm. Maintaining constant temperature across your whole body would cost far too much energy for a fish. Instead you heat only your most vital organs. Your eyes, your brain, and the core muscles that drive your swimming. Your blood vessels run counterflow against one another, forming a countercurrent exchange system. Warm blood recaptures heat, preventing it from spreading across the rest of your body and especially stopping heat loss through your gills. Much of your body stays cold, but the parts that matter for survival always operate at peak performance. This ability is called regional endothermy. Tuna have it. Some sharks have it too. Yet these groups share almost no close common ancestry. This trait was not inherited from a shared ancestor. Along separate evolutionary paths, life arrived at the same solution again and again. You can even actively regulate your body temperature. Scientists fitted recording devices on free-swimming swordfish. They found that when you enter cold deep water, your body cools far more slowly. When you climb back toward warm surface waters, you rewarm rapidly. Researchers believe you actively redirect blood flow. In warm waters, heat spreads freely through your tissues. Once you dive deep, heat gets locked back inside your critical organs. This lets you travel back and forth repeatedly between two completely different worlds. It also makes you the deepest living fish among all large surface-dwelling predators. Still, most people know you not for this superpower, but for your sword. It starts growing even when you are still a larva. Fully grown, it can reach 15 meters long, making up 1/3 of your total body length. Many imagine you stab prey like a knight with a lance. That is not how you hunt. You do not aim at one single fish. You charge straight into a school. Then you snap your head hard from side to side. Your bill is flat horizontally, lined with fine sharp serrations. It acts like a huge high-speed cleaver. One strike, two strikes. Prey gets stunned, cut, and disoriented in an instant. Only then do you open your jaws and swallow them. Sometimes you slice prey into pieces before eating. Your bill also serves as a defensive weapon when danger arrives. What is truly remarkable is not just how sharp it is, but how cleverly it is built. The tip of your bill holds extremely high mineral density, making it rock hard. Closer to your skull, the inner structure grows far more porous. The front end absorbs impact force. The base dissipates shock, even after repeated violent blows. It resists snapping. This unique structure has become an important research sample for scientists studying bone mechanics. More surprising still, your skeleton lacks a cell type found in nearly all land vertebrates. In human bones, osteocytes spot damage. When cracks appear, they signal other cells to begin repairs. For a long time, scientists thought bones could barely heal without osteocytes. You possess what is known as a cellular bone. Even so, fractures get repaired. Your bill keeps remodeling itself. You just rely on a completely different repair mechanism. Scientists are still studying this process, hoping to unlock new ideas for bone regeneration. Even stranger, your distant ancestors did have osteocytes. Over the course of evolution, fish lost this cell type, and this loss happened multiple independent times. When a feature disappears repeatedly across different lineages, it usually brings some real survival advantage. Your ancestors also did not carry this sword. Roughly 60 million years ago, the earliest billfish were not giants. Both upper and lower jaws stretched outward, resembling modern needlefish. One lineage gradually evolved into today's sailfish. Another became you. Fascinatingly, both evolutionary lines independently lost the elongated lower jaw and kept only the upper jaw. Two separate families ended up with two different kinds of sword. Once again, convergent evolution produced nearly identical answers. Your sword is more than a weapon. It works as a streamlined deflector, parting seawater and cutting drag. Even more incredible, special glands sit at the base of your bill. They secrete oil, which spreads through tiny pores across your head. An almost invisible lubricating film makes gliding through water far easier. For decades, no one understood what these glands were for. We now know they exist for one purpose: speed. Human debate over your top speed continues to this day. The old widely quoted figure was 100 kilometers per hour. More recent studies suggest this number is likely overstated. Calculations based on maximum tail muscle contraction estimate your real peak speed sits around 55 kilometers per hour. That is still astonishing. If you swam any faster, cavitation would form around your fins. Collapsing bubbles deliver impacts powerful enough to erode metal. Push harder, and your own body would suffer damage first. Nature did not chase endless top speed. Instead, it struck a balance between speed, power, and endurance. You are not the ocean's largest hunter, nor are you the absolute fastest. You are not the only fish with regional endothermy. Yet few animals cross two utterly different worlds every single day the way you do. From warm sunlit surface down into pitch black abyss, then back up from icy depths towards sunlight once more. Every beat of your body operates near the hard limits of biological possibility. For a swordfish, this is just another ordinary day.